Hello, welcome. This video will cover question number 5 of freshman mathematics, which is found on page 11 of the module. And the question says, which of the following implies that P or Q is given that A is given? We need to prove or check, okay? We need to prove or check whether P or Q is false. So the requirement is that you have to check P or Q is false. What is given? A to E. So the information given here in this question is you have to use the conditions given from A to E and show that P or Q is false. So this is the question. So we'll continue on part A. You can see negation of P or negation of Q is false. Does this condition allow us to conclude that P or Q is false? So what do you have to check? We need to check if P or Q is false. So we have to see if P or Q is false. So we'll start from the given information as usual. What is given? Negation of P or negation of Q is false. So here we have a connective which is disjunction. So disjunction will be false whenever both negation of P and negation of Q are false. Okay, this is direct from the rule of disjunction. So this means if negation of P is false, so if negation of P is false, what do we have? P is true. And also if negation of Q is false, Q is true. So this means what was required? The required information is this one. Does negation of P or negation of Q being false implies that P or Q is false? Now you have reached at a point conclusion that P or Q, because both are true, this will be true or true, which is equivalent to true. So but the question was to check whether the given condition is false, so that the given we conclude that because we have already obtained true, so provided that the negation of P, therefore the negation of P or negation of Q being false, okay, being false, here false mono doesn't imply that P or Q is false, because we have obtained true. So we conclude A doesn't imply the result. So part B, it is given that negation of P or Q being true, does it imply that P or Q is false? That P or Q is false. Okay, this is a question. Okay, the condition is here. So this is negation of P or Q. It is disjunction here. So in general, can we say that P or Q is false whenever negation of P or Q is true? So for example, if we take as an example, okay, let's take that the first negation of P or Q is equivalent to true. Let's assume the first one is false and the second one is true, or otherwise let's assume that negation of P is true and Q is false. So true or false is true. So we have, so this implies P is true and Q is false. So P is true, Q is false. We'll come to here, P or Q. What do you have? P or Q is equivalent to P is true and Q is false. So what do we have here? By the law of disjunction, we have true statement. So this fails to also hold that whenever negation of P or Q is true, it doesn't imply P or Q is false. There may be another alternative that this may be true, but in this case we can not generalize that the negation of P or Q being true doesn't imply that P or Q is false. So question number 3, C. Let's the same question number 5, part C. The negation of P and negation of Q being true doesn't imply that P or Q is false. The negation of P and negation of Q is given as a condition. Okay, the negation of part C, the negation of P and negation of Q being true, okay, being true, does it imply that P or Q is false? This is a question. So we will also again use the property of disjunction and the property of conjunction. Okay, given that here the negation of P and negation of Q is true. As you remember, conjunction will be true whenever both are true. So having this means negation of P is true and also negation of Q is true. So the same, if the negation of P is true, then P is false. Also, if negation of Q is true, Q is false. So now we will come to, so from here we conclude P or Q is having a truth value, false or false, because both Q and P are false from the given information. So false or false is false. So it has provided us that whenever negation of P and negation of Q is true, it implies that P or Q is false. So we have shown. You can also, in other way, you can see that the given information is the negation of P. The given information is the negation of P and negation of Q. This is true. So remember that this one is true, and also it is negation of P and negation of Q can be written as the negation of P or Q. By what? By De Morgan's law. So you see that this is true, the left side is true. Okay, so the negation of some statement is true means this statement is false. Negation of P and Q is true. The left side is true. The negation of something is true means directly you can conclude that the negation of false only be true. So this means here P or Q is false. In general, if the negation of P and the negation of Q is true, so P or Q is false. So I will recommend part D of question number 5. Okay, part D and part E to do it the same way. Thank you for watching. Hello, welcome. My name is Dr. Deraje from Jijiga University. I will be demonstrating the solutions of question number 8 and 7 from the freshman mathematics module, which is given as an exercise on page 12. So the first question, question number 7, we have two propositions, P and Q. The given information is, it is known P implies Q is true. And the question is to determine the truth value of this proposition. The required information is to determine the negation of P and Q by implies P or Q's truth value. So that means you have to check whether this whole compound proposition is either true or false. What can be said about the truth value? This is the question. The truth value of, because it is a proposition, it will be either true or false. We are going to determine whether it is false or true. P implies Q is true. Okay. This given information will help us to determine the truth value of P and the negation of Q. Okay, by implies P or Q. P or negation of P and Q by implies P or Q. How do we do that? Let's try. P implies Q is true means there are three possibilities. Okay, from the rule of implication, this is true. It is given that P implies Q is true. So P implies Q is true. It is equivalent to negation of P or Q. So if you consider, for example, drawing a table and determine the truth value of this compound proposition, let's draw a table. So there are four alternatives here. So finally, the negation of P and Q, column 3, third column, and the fourth column. We will do this, okay? The third column and the fourth column. So that means the negation of P and Q, false by implies true, which is false. False by implies true, which is also false. True by implies true, which will be true. False by implies true, which will be also true. So this is, now the question was to determine the truth value of this compound proposition whenever P implies Q is true. You know that P implies Q will be false only when the first is true and the second is false, which is the second line. The other one is true. So we will now compare these two results. We have to go to the line where P implies Q is true. There are three lines for P implies Q to be true. And we will see that whenever P implies Q is true, correspondingly, the truth value of this compound proposition, when P implies Q is true, one it becomes false, and the other third line it becomes true, and the other fourth line true. So there are two possibilities for the combination of. There are two possibilities. Now you can see that there are two possibilities. Whenever P implies Q is true, okay, the negation of P and Q by implies P or Q can be true or also can be false, as we have seen. So here it has become false by this choice. Here it has become true. You can see there are two possibilities. So what can be said about? The question was, what can be said about the truth value, about what can be said about the truth value of this proposition? The question was this one, the truth value of this. So it can be said about that this proposition can have both possibilities. It can be true or it can be false. It can be true or it can be false. So using this tabular method, we can show that whenever P implies Q is true, our compound proposition may be false or it may be true. So this is how you can do it using a table. We can also follow algebraic. We can also follow algebraic way to determine the truth value of this statement, the negation of P and Q by implies P or Q. If you simplify it, if we simplify this proposition, we can use simplify using rules of conjunction and also because it is by implication, you can see that here the negation of P and Q implies P or Q, and P or Q implies again the negation of P and Q. These are the two possibilities. So this is equivalent to, we have changed by implication into two implications using this conjunction. So the first one, implication is equivalent to the negation of P, and by De Morgan's law, this is negation of P of negation P, it will be P, and here it will become Q, negation of Q, or P or Q. So there is no another bracket needed because all are disjunctions. We have reduced into similar. Here we have also negation of P, or will change into and here you have negation of Q, or negation of P and Q. So again we will continue. Here negation of P and Q can be reduced by using commutative and associativity property together. P or P is the same as P. Negation of P, Q, or negation of Q or Q. So here, and you can see that here, you can see here one negation of P is here, another negation of P is here. By the reverse law of distributivity, this will be the negation of Q or Q. Okay, so we have this on the is equivalent to, this is also always a tautology, and here we have the negation of P, and here also true. So finally you can see that this is P or T is T, because tautology disjunction with any proposition P is tautology, and here we have, and the negation of P or P, sorry, a tautology with disjunction with P is always a tautology, and here also the disjunction between a tautology and a proposition is the proposition itself. So lastly, you can see that our result has reduced into tautology and negation of P, which takes result for negation of P. So negation of P takes two possibility of truth values. One is false and the other is true. So even if we haven't used the given information, whether you use it or not, you have finally reached at negation of P. Actually, there is no place to use the given information in this simplification. Even if we have been given that P implies Q is true, to determine, given us a given information that P implies Q is true, okay? Even if we have been given that P implies Q being true, to determine the truth value of the negation of P and Q by implies P and P or Q. Finally, this has reduced into the negation of P, which can take either true or false. What we can conclude is whatever given information is has reduced into negation of P, and value is, it can be true or false because it is equivalent to negation of. Thank you for watching. So so question number 7, in conclusion, we have reached that simplifying the compound proposition, even if the value of P implies Q is given to be true, we can say that P, negation of P and Q by implies P or Q can take both true and false truth values. That is our conclusion. We will continue to do question number 8. So the first part A, says that suppose the value of P implies, what can be said about the values of P by implies negation of Q and negation of P by implies Q. So it is given that question number 8A, P by implies Q is true. This is given true. This is given information. What's required? It is expected from us that ከኛ የሚጠበቀው we have to show that if P by implies, we have to determine the truth value of this and also the truth value of the negation of P by implies Q. Okay, so ለዚህ ሶሉሽን የሚረዳን ምንድን ነው? የባይ ኢምፕሊኬሽንን የባይ ኢምፕሊኬሽን ሩልን ማስታወስ ነው። there are two cases. Okay, case 1 when both P and Q are true. Okay, when both P is true and Q is true. ሁለቱም, that means now P is true, also Q is true. This means P is true and also negation of Q is false because P is true. So to do the first one, የመጀመሪያው this implies P by implies negation of Q is equivalent to P is true by implies negation of Q, which is false. So this is actually false by the rule of by implication. By implication will be false when we have two different connectives, the truth values. That means the first is true. Okay, true by implies false is false. So case 1 is over. That means the truth value of P by implies negation of Q is, the truth value of P by implies negation of Q is false. The second case, P by implies Q is true. Okay, the given information, P by implies Q is true whenever both are false. Okay, whenever both P, Q are false, that means P is false and Q is false. So this means negation of P is true step by step. This is called direct proof. By the way, direct proof ነው የሚባለው። ቀጥታ ከአንዱ ስቴፕ ወደ አንዱ ኮንስትራክት እያደረግን ነው የሚሄደው። ስለዚህ the negation of P by implies Q is equivalent to, because now we have determined the truth values, directly substitute አድርገን true by implies false, which is false. So now we have determined the truth value of pose. We have determined the truth value of pose P by implies negation of Q and negation of P by implies Q. We have determined the truth. Having known that P by implies Q is true, we have determined the truth value of pose to be false. Okay, pose to be false here. Here also false. So this is how you can directly determine. You can use also tabular method. Okay. So for all of you.